In 1977, amid transformative global events like the rise of personal computing and the final Viking Mars landings, Voyager 1 launched toward the stars. Originally designed to study Jupiter and Saturn, its mission soon expanded into uncharted territory, beyond the solar system and into interstellar space. Today, 46 years later, Voyager 1 drifts silently some 23.5 billion kilometers from Earth, a lonely ambassador carrying the dreams and curiosity of humankind. Its groundbreaking discoveries have reshaped scientific understanding, revealing that the cosmos is far stranger, and more dynamic, than we once imagined. One of its most surprising revelations was the strength and complexity of magnetic fields beyond the solar system. Scientists once believed the Sun's magnetic influence faded at the heliopause, the boundary where the solar wind meets interstellar space. But Voyager 1 detected tangled, dynamic magnetic fields far past this boundary, suggesting that the Sun and interstellar space interact more intricately than expected. This discovery has real-world implications. Cosmic magnetic fields play a major role in shielding or exposing astronauts to dangerous radiation. Voyager found that cosmic rays beyond the heliosphere are up to 1,000 times more intense than those near Earth. These high-energy particles, born from dying stars and supermassive black holes, easily penetrate the weakened defenses of our solar bubble, posing a major challenge for future Mars missions and long-term space habitation. Engineers are now exploring active shielding technologies, such as magnetic deflectors, to protect astronauts venturing beyond Earth's protective embrace. Another surprise came from Voyager's plasma wave instrument, which detected sharp, irregular spikes in interstellar plasma density, some as much as 40 times denser than models had predicted. Rather than a calm and uniform void, interstellar space appeared turbulent, shaped by distant supernova shockwaves and stellar winds. This new understanding is pushing engineers to develop more resilient materials and adaptive systems capable of withstanding the chaos of deep space. Voyager's observations also challenged our assumptions about the heliosphere's shape. Once thought to resemble a comet with a long trailing tail, new data suggests it may be more irregular and porous. A leaky heliosphere means Earth is more exposed to cosmic radiation than previously believed, raising concerns not just for space missions, but for satellite systems and infrastructure vulnerable to solar and cosmic events. Among Voyager's most haunting discoveries are the eerie sounds of interstellar space, plasma vibrations converted into ghostly hums and high-pitched whistles. These strange sonic signals shift with solar activity, offering clues about particle density and magnetic turbulence. For scientists, they are not just data, but a sonic fingerprint of the universe's hidden forces, a blend of science and poetry drifting through the stars. The longevity of Voyager's mission has been made possible by its radioisotope thermoelectric generator, or RTG, which converts heat from decaying plutonium-238 into electricity. Though the output drops by about 4 watts each year, engineers have carefully managed its limited power by shutting down non-essential systems, including its iconic cameras. Today, only 3 instruments remain active, collecting data on cosmic rays, plasma, and magnetic fields. By 2030, even these will go silent, leaving Voyager drifting forever in the interstellar night. But its message will endure. The spacecraft carries a golden record, a time capsule curated by a team led by Carl Sagan. It contains 116 images, from DNA diagrams to everyday life on Earth, along with 90 minutes of global music, from Senegalese percussion to Beethoven symphonies. Etched with instructions in binary and a controversial pulsar map pinpointing Earth's location, the record could last 1 billion years, far beyond the lifespan of our planet. Voyager's most iconic legacy may be the pale blue dot photograph, an image of Earth as a tiny, 0.12 pixel speck beneath Saturn's rings. Sagan's reflection, "Look again at that dot," remains a timeless reminder of our shared fragility. The image continues to inspire calls for unity, climate action, and a shift in perspective, from division to togetherness. Voyager's journey isn't just about exploration, it's about redefining what's possible. Its legacy now fuels the next generation of interstellar missions. NASA's Interstellar Probe, set to launch around 2030, aims to study the true shape of the heliosphere with more advanced instruments. Private projects like Breakthrough Starshot envision tiny, laser-propelled spacecraft reaching Alpha Centauri in a generation, carrying forward Voyager's fearless spirit. Yet Voyager also highlights the limits of communication in deep space. Its signals, traveling at the speed of light, take over 22 hours to reach Earth. The data comes through NASA's Deep Space Network at just 160 bits per second, slower than 1980s dial-up. But every bit holds insights that continue to revolutionize our understanding of space. Voyager 1 is more than a spacecraft, it is a symbol of humanity's relentless curiosity. From a planetary scout to an interstellar pioneer, it has defied the constraints of age, distance, and time. It teaches us that exploration is not about instant answers, but about patient, persistent inquiry. A lesson as vital for science as it is for life on Earth. As its power fades, Voyager whispers a final truth: mystery fuels progress. The universe, vast and ever-changing, calls us to keep questioning, discovering, and daring. Long after its systems go dark, Voyager 1 will continue to orbit the Milky Way, a silent monument to what humans can achieve when they reach for the stars.